P0306 is a cylinder 6 misfire. In plain terms, the PCM is seeing cylinder 6 slow the crankshaft differently than the other cylinders. The driver may notice a rough idle, shake under load, lack of power, or a MIL that may illuminate or flash. On this engine, possible fault areas can include ignition, fuel delivery, air leaks, oiling and VVT operation, mechanical cylinder sealing, valvetrain issues, wiring, connectors, and in the last part of the path, PCM control. Start with the basic system checks first. Also remember, during a severe misfire with a flashing MIL, the PCM can shut off the affected injector to protect the catalytic converter, and stop/start may be disabled while this code is active. Anything that changes crankshaft speed can set this kind of code, so don't assume the first component you touch is failed. For the monitor to run, the operating gates have to be valid. Fuel level above 12%, battery voltage above 10. 9 volts, ambient temperature above -23 degrees C -9. 4 degrees F, coolant temperature at engine start above -7 degrees C 19. 4 degrees F, engine temperature reaching 21 degrees C 69. 8 degrees F when needed, and engine speed between approximately 400 RPM and 6,200 RPM. The misfire monitor is disabled during a decel fuel shutoff event. The code sets when the crankshaft speed variation between cylinders exceeds a calibrated value for the current speed and load. Turn the ignition on, then use the scan tool to read and record all codes and captured operating data. Drive or operate the truck under the same captured conditions from when the code set. During the drive, pay attention to when the cylinder 6 misfire shows up, because that matters later. Watch the downstream oxygen sensors while the misfire is happening. Readings that stay low can point toward a lean condition, like a restricted injector or fuel supply problem. Readings that stay high can point toward a rich condition, like lack of spark or a leaking injector. Then look at the misfire monitor and confirm whether cylinder 6 is showing excessive misfires right now. If it is, continue the diagnostic path. If it is not active, handle it as an intermittent condition. One more thing. If the misfire only happens at high RPM or heavy load, injector shutoff can make it look like the misfire continues back at idle until the counter resets. So interpret the monitor carefully. Next, look at the codes you recorded. If there are known bulletins or active or pending faults related to fuel, ignition, air handling, or VVT, diagnose those first instead of treating P0306 in isolation. At this decision point, the printed follow-up branch for a clean result is unclear, so don't guess a skip. Pause, recheck the earlier diagnostic path, and make sure you are not missing a related fault. Then make a broad inspection. Look for belt wear, accessory pulley misalignment or binding, sensor mounting problems at the crank, cam, or MAP sensors, poor connector or terminal contact at key engine components, PCM power or ground corrosion, vacuum leaks, air intake or exhaust restriction, internal engine trouble, moisture on ignition parts, fuel supply or fuel quality concerns, bogging or overload conditions. Repair anything you actually find. If nothing is found here, the printed follow-up branch is also unclear. So again, pause and recheck the diagnostic path rather than jumping ahead blindly. Before going deeper, check oil level and oil condition. Low oil, the wrong oil filter, wrong viscosity, dirty or contaminated oil, aerated oil, oil pressure concerns, or mechanical tolerance issues can affect VVT operation and create a misfire. If an oiling or mechanical condition is present, repair that condition and verify the repair. If not, check the engine and intake manifold for vacuum leaks. A vacuum leak can affect one cylinder or more than one, depending on where it is. If a leak is found, repair it and verify. If the intake is sealed, check the fuel for water, the correct type, old or contaminated fuel and low fuel level, and perform the ethanol level check. If fuel problems are found, replace the fuel and if needed, flush and clean the fuel system, then verify the repair. Before opening fuel lines or fittings, release fuel system pressure. The fuel system can stay under constant pressure even with the engine off. and ignoring that can cause serious injury. Now check whether the cylinder 6 injector is clogged or leaking. Install fuel pressure decay tester 8978A at the fuel rail. Turn the ignition on. Let pressure reach maximum and stabilize, and record that as starting pressure. You may need to cycle the ignition off and on a couple of times to build maximum rail pressure. Use the scan tool to actuate the injector for the misfiring cylinder while watching the pressure gauge. Then record the ending pressure. After each injector actuation, start the engine to clear fuel from the cylinder, skipping that can damage the engine. Repeat the same process on several good cylinders, always starting each injector test at the same starting pressure. Compare the ending pressures. If cylinder 6 is about the same as the good cylinders, move on to spark testing. If cylinder 6 stands out, a small pressure drop means check for debris in the rail or injector and repair as needed. A large pressure drop points toward a faulty or fouled injector issue, then verify the repair. A single injector problem usually shows the highest misfire count on that cylinder, though excessive fuel can also affect an adjoining cylinder. After injector testing, turn the ignition off, remove the fuel pressure decay tester, and reconnect the fuel lines before continuing. Remove the cylinder 6 ignition coil, reconnect the coil connector, disconnect the cylinder 6 fuel injector connector, install a spark tester on the coil, and crank the engine while watching the spark. A crisp blue spark sends you to the spark plug and cylinder inspection. No crisp blue spark sends you into the ignition coil circuit checks. If spark is good, turn the ignition off and remove the spark plug. Inspect it for cracks, carbon tracking, oil, coolant, excess fuel fouling, incorrect gap, or a loose or broken electrode. Also look for oil or coolant in the cylinder. If those plug problems are present, replace the spark plug. If oil or coolant is present, diagnose and repair the reason it got there. Then verify the repair. If the plug and cylinder inspection does not show a problem, run a compression test on several cylinders and compare the good cylinders to cylinder 6. If compression is within specification, continue. If it is not, perform a cylinder leak down test to decide whether the problem is in the valvetrain or combustion chamber, repair as needed, and verify. Ignition parts may misfire at idle or only under heavy load, and a compression or valvetrain issue often shows up across operating conditions, usually with the strongest count on the problem cylinder. If compression checks out, move the cylinder 6 spark plug to a known good cylinder, or replace it if access makes swapping impractical. Start the engine and watch the misfire monitor. If the misfire moves with the plug, replace the spark plug. If the plug was replaced and the misfire is gone, that completes that repair path. Then verify. If the misfire does not move and does not go away, clean carbon from the valvetrain and combustion chambers using MOPR combustion cleaner. After driving and clearing the cleaner from the engine, erase the codes, test drive under the captured conditions, and watch the misfire monitor again. If the misfire does not return, the cleaning corrected the fault. Then verify. If it returns, visually inspect the camshaft lobes, rocker arms, and springs for excessive wear or broken parts. Repair confirmed issues and verify. Worn cam lobes, worn or broken rocker arms, or spring problems may not always show up on a compression test, so this visual check matters. If the spark test did not show a crisp blue spark, go electrical. With the ignition off, disconnect the ignition coil connector. Turn the ignition on, command the ASD relay with the scan tool, and use a 12-volt test light connected to ground to probe the ASD relay F344 output at the coil connector. If the light does not illuminate brightly, stop all scan tool actuations and repair the open or short to ground between the PDC and the coil connector, then verify. If the feed is good, test coil control. Use a 12-volt test light connected to a 12-volt source, back probe the coil control circuit at the coil connector, and crank the engine for 5 seconds. If the light blinks brightly, replace the ignition coil and verify. If the light stays on constantly, check the coil control circuit for a short to ground. Turn the ignition off, disconnect PCMC2, Install the GPEC Diagnostic 10436 adapter on the engine harness side and check continuity between ground and the coil control circuit. If continuity is present, repair the short to ground and verify. If the test light stayed off constantly during the control test, measure resistance in the coil control circuit between the coil connector and the GPEC adapter. If resistance is below 3.0 ohms, continue to the harness and PCM connection check. If it is not below 3.0 ohms, repair the open or high resistance and verify. When the engine is operating, stay out of line with the fan, keep hands away from belts, pulleys, and the fan, and avoid loose clothing. Also, do not probe PCM harness connectors directly. Use the adapter so you do not damage the terminals. For the final connection check, disconnect the PCM connectors, related inline connectors if equipped, and the related component connectors. Inspect the connectors and terminals for proper seating, damaged locks, corrosion, water intrusion, whether seal damage, bent terminals, overheating, push-back terminals, spread terminals, and poor terminal tension. Repair any confirmed condition. Reconnect everything fully and make sure the locks are engaged. Then erase the codes and operate or test drive the vehicle under the monitored and captured conditions, and read codes again. If P0306 returns after the harness and connection checks, replace and program the PCM, then verify the repair. If it does not return, the wiring or poor connection issue has been repaired. Keep the verification separate from the testing. Clear the code, reproduce the operating conditions, and confirm the misfire stays gone. The takeaway is simple. Prove whether cylinder 6 is losing fuel control, spark, compression, valve action, or electrical control before calling the repair. For more diagnostic training, visit stepdiagnostics.com.